Hello there, and welcome back to the Science Sleepy Minds. Tonight, you're floating in perfect stillness. There's no air, no sound, no light, just an infinite velvet black hush stretching in every direction. You're not even sure if you're moving because how would you know? There's nothing to compare yourself to. And for a moment you think, this must be it. Nothing. But don't get too cozy because just as you're settling in, a twitch runs through the dark. A ripple, a sigh of something. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, drop a comment with your location and the local time, because nothingness is weirdly more fun when we experience it together. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You stare into the dark and try to imagine what true nothingness feels like. Not just an empty room or a dark sky, but an utter absence. No atoms, no energy, no time, no space. But here's the first problem. Your brain isn't wired to picture that. You're a walking pile of pattern-hungry neurons trained to find meaning in cloud shapes and toaster crumbs. So when you try to imagine nothing, you probably end up visualizing something. Blackness, silence, a vacuum, a void. Still something. The ancient Greeks had this issue too. As early as 5th century BCE, they debated what happens when you take everything away. Some, like Parmenides, boldly declared that nothing doesn't and can't exist. After all, if you can talk about it, it must be something, right? His logic was annoyingly airtight. He insisted that thinking about non-being was already giving it being. Classic philosopher move. Then there's the sensory problem. You've never experienced true nothing. Even in a sensory deprivation tank, you're still floating in water, surrounded by air, thinking your thoughts. You are the something, ruining the nothing. It's like trying to see pitch black with a flashlight taped to your forehead. Here's your first wild fact. Even when astronauts float in the vacuum of space, they're still not in nothing. Space is filled with virtual particles, magnetic fields, stray hydrogen atoms, and a smattering of leftover photons from the Big Bang. It's like a fridge that you think is empty, until you realize there's a weird half jar of mustard in the back. So did nothing ever exist? Well, depends on how picky you want to be. If you define nothing as the absence of all matter, okay, maybe. If you mean the absence of energy, now we're getting shaky. If you mean the absence of laws, dimensions, or potential, then we're straight up lost. And yet for millennia, humans have been obsessed with the idea. It's not just a physics question. It's theological, philosophical, even poetic. What was before the universe? What happens after we die? What's the value of something if nothing could have existed instead? These aren't questions with neat answers, but they are very comfy for late-night pondering, especially when your sleep playlist loops and your brain quietly betrays you with existential dread. Let's go a little deeper into that velvet dark. Somewhere beyond your perception, particles blink into existence like faulty Christmas lights and vanish again before the universe finishes noticing. Welcome to quantum field theory, where even empty space is just a playground for unpredictable fluctuations. But hold on. We'll get to that dance party later. For now, imagine the raw, pre-universe state if such a thing ever existed. No time, no causality, not even the tiniest pixel of light, a true cosmic zero. And yet somehow that nothing birthed everything, or so the story goes. And let's be honest, it sounds suspicious. Like when your sibling swears the cookie jar just broke by itself. Sure it did. Modern physics likes to dance around the idea of nothing, sometimes treating it like a vacuum, other times like a seething foam of uncertainty. It's not even clear we can define it anymore. Is nothing a state, a substance, a potential? Historians still argue whether ancient concepts of the void were truly philosophical or just linguistic illusions. After all, if your language lacks a word for nothing, can you really grasp the idea? But maybe we've been asking the wrong question. Maybe the better one is, why is there something instead of nothing? That line goes way back, at least to Leibniz in the 18th century, but it still gnaws at modern thinkers. What if something is just the natural state and nothing was never even on the menu. Fringe theories love this kind of talk. Some suggest that nothing is unstable, like a pencil balanced on its tip. It was always going to tip into something. Others argue that nothing was just a temporary illusion in a multiverse of constant emergence. Either way, the nothing we imagine, calm, silent, blank, is probably a bedtime myth. Sorry. You float on deeper now, past the blackness, past even the idea of space. Here in this imaginary nowhere, your mind wobbles. It wants landmarks, a grid, a north. But there isn't one, just a heavy, patient stillness that you keep trying to name. And the second you name it, it's no longer nothing. It's a concept. And concepts have mass, at least emotionally. One last thought before you drift. Even if we could find nothing, how would we know? What device could measure it? What observation could confirm it? It's the ultimate paradox. A thing that doesn't exist, can't be detected, can't be defined, yet somehow still lingers in your thoughts, whispering bedtime riddles you'll never solve. But that's the charm of nothing. It gives your brain just enough to do while the rest of you shuts down. Like giving a toddler a cardboard box to play with while the grown-ups talk physics in the next room. You're still floating, except now you're surrounded by sand, sandals, and suspiciously bearded philosophers. Ancient minds weathered by sun and the occasional plague gather under fig trees and clay-roofed forums, tossing around ideas that will later become foundation stones for entire civilizations. And at the center of their heated debates, this baffling little concept called nothing. You sit cross-legged on the stone floor, eavesdropping as if it's the gossip of the century, which, to be fair, it sort of is. Long before telescopes and particle accelerators, people stared up at the night sky and wondered not just what was out there, but how much nothing separated those twinkling dots. Did the stars float in some celestial jelly, or was it pure emptiness? You can almost hear them arguing between sips of wine, though half of them are definitely using the word nothing to avoid admitting they don't know. Take the ancient Vedas of India, for instance. Thousands of years ago, their creation hymns toyed with the idea that before existence, there was neither being nor non-being, which is either very deep or very confusing, probably both. The Rigveda even says, "Who really knows?" which, considering it was written before indoor plumbing, feels refreshingly honest. Meanwhile, over in Greece, Parmenides is taking a very aggressive stance. His big idea, nothing cannot exist. You try to tell him that sounds dramatic, but he's busy declaring that what is, and what is not. It's like arguing with a rock appropriate, since his surviving work is literally carved in stone. Parmenides claimed that change itself is an illusion, because change requires non-being to become being, and that to him was nonsense. His logic, sharp as it is, makes you want a nap. And honestly, that's fair because you, a modern human with internet access, know deep down that things do change. Ice melts, people age. Coffee disappears from cups mysteriously, usually into your face. So if change is real, was Parmenides just wrong? Or is the universe gaslighting us? Not everyone agreed with him, even back then. His frenemy Heraclitus said the opposite. Everything is change. You can't step in the same river twice, he said, mainly because rivers are busy doing river things like flowing and flooding your sandals. In Heraclitus's world, nothing is constantly giving way to something, and vice versa. Very poetic, slightly chaotic, kind of beautiful. Later thinkers tried to bridge this divide. Plato, lounging in his ideal realm of forms, suggested that the material world is just a flawed reflection of timeless truths. So the things we see, dogs, chairs, mediocre olives, aren't the realist real. They're pale copies of their perfect versions. But even Plato skirted around nothing. He liked abstraction but stopped short of full-on void worship. Aristotle, on the other hand, comes storming in with scrolls and structure. He absolutely hates the void, can't stand it, says nature abhors it actually. That's right, he's the original anti-void influencer. In his worldview, everything is made of four elements: earth, air, fire, water, and everything has a purpose, a direction, a reason to move. To Aristotle, empty space makes no sense because movement needs contact. No push, no pull, then no go. You imagine him standing on a balcony, arms folded, insisting that even the spaces between things must be filled with something. The idea of a pure vacuum, pure nonsense. And for the next 2,000 years, most of Europe agrees with him. That's the power of charisma, my friend. Meanwhile, far from Mediterranean philosophers, ancient Chinese cosmology also dips its toes into the void. The Tao Te Ching describes the usefulness of emptiness. We shape clay into a pot, but it is the emptiness inside that holds whatever we want. So here, nothing isn't absence, it's function. It's the space that makes space useful. A surprisingly practical way to think about it, and honestly, kind of comforting. But if you really want to feel your eyebrows rise, consider this fringe tidbit. Some early Jewish mysticism describes creation not as adding something into nothing, but as withdrawing God from a space to allow the universe to form. A divine pulling back to create room. That's right, God makes the world by stepping away. It's called tzimtzum, and yes, it's as poetic as it sounds. Historians still argue whether these early mythologies genuinely wrestled with the concept of nothing, or simply treated it as a narrative placeholder. After all, it's hard to distinguish between nothing as a literal state and nothing as a dramatic flair. When a creation myth says, "In the beginning there was nothing," does it mean nothing in the cosmic sense, or just no humans, no drama, no taxes yet? And here's a fun twist. Some linguists argue that early languages didn't even have a proper word for nothing. They had words for not here, or not this, but not a universal, abstract absence, which makes you wonder, did nothing exist as a concept before the word for it did? Or is this one of those chicken and egg scenarios, but with slightly more existential panic? Still, for all their varied takes, ancient thinkers return again and again to the same core question. Can something come from nothing? If yes, then nothing is somehow fertile. And if not, then maybe nothing has never truly existed, just like the clean sock you're always trying to find in the laundry. So you sit there, surrounded by ancient thought experiments and slightly uncomfortable togas, realizing this isn't going to get simpler anytime soon. You're stuck with a word that defines itself by not being anything, and yet constantly sneaks into conversations about creation, change, time, and meaning. And that, dear sleeper, is how ancient minds made nothing into the most complicated something of all. You're lying flat on a marble floor now, the kind that reflects light in that clean, geometric way that screams ancient Greece had too much time and too many slaves. And above you, packing like a man on a mission, is Aristotle, robe swishing, brows furrowed, fingers tapping on a scroll that frankly looks like it's been copied 12 too many times. He's not yelling exactly, but you can feel the tension in his voice, because he is absolutely, categorically, philosophically done with the idea of nothing. To Aristotle, nothing is an insult to reason, a void, a vacuum, the absence of substance, purpose, or function, rubbish. Nature, he says, doesn't tolerate gaps. Just as water rushes in to fill a hole in the earth, the cosmos will not allow emptiness to linger. You almost feel bad for nothing. It's been canceled by one of the most influential minds in Western history. This is a guy who sees the universe as a series of interlocking causes. Everything has a reason, and nothing happens without something else setting it in motion. Substance and form, potential and actuality, it's all very organized. So the idea of a void, a literal absence of being, it short-circuits his whole metaphysical operating system. It's like installing a trapdoor in the middle of a brick wall just to spite the wall. Aristotle's rejection of nothingness wasn't just a quirky opinion. It shaped science, theology, and logic for over 2 millennia. His influence was so massive that later thinkers, especially during the Islamic Golden Age and the Scholastic period in Europe, built entire systems on his back. You picture a medieval monk scribbling Latin into candlelight, nervously citing Aristotle just to avoid excommunication. And here's your mainstream historical fact. For centuries, European scholars believed that vacuums were physically impossible, not just unlikely but forbidden by nature itself. No one thought you could create a space with absolutely nothing in it. If you tried, nature would somehow fill it, because Aristotle said so. The phrase nature abhors a vacuum became more than a metaphor, it was doctrine. Engineers and alchemists alike were baffled when trying to suck air from containers. Something always seemed to go wrong. Pumps broke. Water refused to behave. People began to think the universe was sabotaging them. And honestly, given what we now know about pressure differentials and fluid dynamics, the universe kind of was. Even the Catholic Church, during its long era of don't ask too many questions, took Aristotle's word almost as gospel. He wasn't just a philosopher, he was the philosopher. So if he said there was no such thing as nothing, well then, that was that. But fringe thinkers, oh, they had a field day. Renaissance magicians and proto-scientists started poking holes in the vacuum taboo. A few even suggested that perhaps the universe had little cracks, places where being thinned out, where matter flickered like a weak candle. These weren't exactly respected views, but they hung around like philosophical lint. Here's your quirky tidbit. In the 17th century, people believed that suction, the kind that makes your boba tea straw work, was caused by nature's fear of empty space. Not air pressure, not mechanics, just the cosmos having an anxiety attack over nothingness. It's both hilarious and deeply poetic. Historians still argue whether Aristotle's hardline anti-void stance was a genuine empirical observation or just a logical overreach. After all, he didn't have vacuums to test, just clever arguments and some oil lamps. Some say he was working from common sense. We don't see emptiness, therefore it must not exist. Others think he was protecting his tidy metaphysics from collapsing under its own weight. Either way, his ideas got sticky. Even when future scientists like Galileo and Torricelli started proving the vacuum was possible, Aristotle's legacy made people twitchy. You picture an old scholar clutching his robes as mercury levels drop inside a glass tube, muttering, "This can't be happening." Back in your dreamlike marble hall, Aristotle continues packing, muttering about form and matter. You try to interrupt, just a little. You suggest that maybe nothingness isn't the enemy, maybe it's just misunderstood. He gives you a look like you've asked if ducks can be philosophers. Spoiler, he once wrote about duck behavior but never their opinions on voids. Still, his refusal to allow for nothing did force later thinkers to get creative. If you can't have a literal vacuum, you have to explain motion, change, and space without it. That led to increasingly elaborate models of how the universe was filled, completely, with stuff. Even light and thought had to wiggle their way through cosmic density. And yet, even within Aristotle's iron logic, there's an uncomfortable tension. If every object needs a place to be and no two things can occupy the same place, then doesn't that imply space must exist separately from objects? That is, some kind of container, even if not nothing, is needed to hold the something. You press the question gently, but Aristotle just folds his arms, unimpressed. You lie back down, letting the debate echo above you. It's almost comforting, this insistence on order. In Aristotle's world, there are no cosmic loopholes, no lurking voids, no spontaneous disappearances. The universe behaves, and there's something soothing about that, like putting all your existential dread into a filing cabinet and locking it with a key labeled logic. But even as you drift, your mind begins to wander. If Aristotle was so against the idea of nothing, then why do we keep coming back to it? Why does it haunt physics, theology, and dreams alike? Maybe, you think, it's because nothing isn't just a concept, it's a mirror. One that reflects our fear, our curiosity, and our insatiable need to fill silence with meaning. As you fade out of the colonnades and into darker, quieter realms, one truth lingers. For all his brilliance, Aristotle may have buried nothing, but he didn't kill it. You blink and the marble fades. The robes, the scrolls, the sandal dust, they all dissolve into flickering specks, like ash caught in a sunbeam. What replaces them is older still, in a strange way, simpler, bolder, and more atomically committed. You're standing in an open field of thought now, just outside the comfort zone of classical philosophy. And approaching across this barren intellectual terrain are two cheeky rebels with a theory that would give Aristotle a heart attack. Meet Leucippus and Democritus, Greek thinkers from the 5th century BCE who don't just believe in the void. They depend on it. You hear the rustle of their logic before you see them, a wind of tiny, invisible pieces, clattering against each other in an infinite dance across the emptiness. These are the atomists, the ones who claim that everything in existence is made from indivisible particles, atoms, and the void in which they move. You're going to want to sit down for this one, preferably on a solid patch of vacuum. Their idea is seductively simple. Reality consists of two things, atoms and the void. Atoms are eternal, unchangeable, and in constant motion. The void, it's not a glitch in the system, but a necessary condition for the system to exist. Without empty space between atoms, nothing could move, nothing could collide, nothing could be. You suddenly understand why Aristotle was so cranky about it. It's everything he hated. Motion without purpose, form without a container, nothing being essential. To Democritus, the void wasn't scary. It was liberating. It allowed for the dynamic, chaotic, self-regulating universe he imagined, a universe that didn't need divine puppeteers or crystal spheres to explain itself. He famously said, "Nothing exists except atoms and the void. Everything else is opinion." Bold. Definitely the kind of guy who answers rhetorical questions on purpose. And here's your mainstream historical fact. Democritus's atomic theory, though rejected by the dominant schools of thought for centuries, was later vindicated by the scientific revolution, leading directly to our modern understanding of molecules, matter, and quantum fields. But in his own time, he was kind of the odd uncle of Greek philosophy. Brilliant, but way too comfortable with uncertainty. Now picture this. Aristotle's cozy universe filled with elements and purpose is being slowly undermined by these rogue thinkers whispering about infinite space. You can almost hear the crack forming in the metaphysical wallpaper. And if that doesn't wake you up, here's your quirky tidbit. Epicurus, a later atomist who adored Democritus's ideas, added that atoms could randomly swerve while falling through the void, introducing the concept of spontaneity, just so he could explain free will. That's right, the ancient Greeks invented quantum weirdness because they wanted to justify bad decisions. Historians still argue whether Democritus actually came up with the idea of atoms independently or was borrowing from even earlier sources, possibly from the East. There's evidence that Indian Jain thinkers also believed in indivisible elements and empty space. But while the origins remain debatable, what's clear is that these ancient atomists were leagues ahead of their time. You drift now, floating between tiny, indestructible bits of matter as they whirl past you in unpredictable patterns. Some collide and form stars. Some group into living cells. Others drift endlessly, never touching anything. And in every direction around them is nothing, or to be more precise, something labeled nothing. The void in this picture is not passive. It's the stage, the canvas, the silence between notes. It allows the structure of reality to emerge from endless collisions and recombinations. Without it, atoms would have nowhere to go, no room to breathe, no freedom to assemble into complicated things like brains, burritos, or really long YouTube scripts. It's almost comforting, this ancient vision of a universe that doesn't need a creator, just particles in space. You think about it. No divine clockmaker, no metaphysical scaffolding. Just little bits bouncing around like cosmic pinballs, with the occasional lucky strike leading to sentient playlists and existential commentary. But of course, most people didn't like this theory back then. It felt cold, impersonal. The idea that love, art, even dreams were just atomic shuffles was too much for traditionalists. And the void itself, it was a problem no one wanted to solve. If you can't see it, feel it, or hold it, how can you prove it's real? So the atomists were sidelined. Their scrolls copied half-heartedly, their theories quietly ignored in favor of more satisfying, purpose-driven cosmologies. But like most good ideas, atomism didn't disappear. It just went underground, hibernating in the dusty corners of philosophy, waiting for a less Aristotle-crazed generation to rediscover it. And rediscover it they did, nearly 2,000 years later. You'll get there soon. But for now, you linger in this early moment where nothing gets its first meaningful job, not as an error or a void to be avoided, but as the very space in which reality unfolds. The air here feels thin, weightless. You reach out your hand and, well, you can't touch the void, but you feel its implication. It's not cold, it's not dark, it's necessary. And somehow that makes it less scary. Not a monster hiding under the bed, but the bed frame itself. You float a little longer, letting atoms zip by like lazy fireflies, each on its tiny mission. Somewhere, an ancient Greek is smiling with the smugness of being correct way too early. You nod in his general direction and drift deeper into the quiet hum of the early universe, where nothingness isn't gone, it's just finally doing something useful. You land with a soft thunk onto parchment, ink stains, and candlelight. The air smells like old wood and theological anxiety. You're in the Middle Ages now, and nothing has taken on a brand new job, proving the existence of God, or maybe disproving it. Depends on who's holding the chalk. Gone are the atomists and their cheery chaos. You're now in the era of scholastic philosophers, robed, bearded, and chronically undercaffeinated. They're trying to reconcile Aristotle with the Bible, and they've got a serious nothing problem on their hands. Because here's the theological twist. If God created the universe, then he must have created it from something, or more terrifyingly from nothing. And that idea, creatio ex nihilo, becomes one of the most important and hotly contested claims in religious thought. You pull your cloak tighter. Things are about to get metaphysically intense. Early Christian thinkers like Augustine took a hard stance. Yes, God created everything from nothing. Not empty space, not a pre-existing chaos, nothing at all. Not even time existed before creation. It was the ultimate cosmic mic drop. You don't just make a universe, you make the very concept of making. And here's your mainstream historical fact. By the 4th century CE, creation from nothing was the official position of mainstream Christian theology. It sharply distinguished the Christian view from earlier Greek ideas of eternal matter or cyclic creation. No leftovers, no recycling. Just a divine finger snap and boom, existence. But then the philosophers showed up. Boethius, Anselm, Aquinas, they all wanted to make faith logical, and that's where the trouble starts. Because to them, nothing wasn't just poetic, it had to be rational. If God made everything from nothing, then what was the nature of that nothing? And if it had no nature, are we even allowed to talk about it? You lean over a scholar's shoulder as he sketches a diagram showing being flowing from non-being like wine poured into a cup that isn't there. It makes your head hurt, but in that dreamy way that helps you fall asleep just a little bit faster. Then you hear whispers, Islamic philosophers, Jewish mystics, everyone tossing around the void like an eternal hot potato. In the Islamic Golden Age, thinkers like Al-Farabi and Avicenna debated whether nothingness could be a real state or just the absence of something more meaningful. And in Kabbalistic thought, the universe begins with divine withdrawal, creating a sacred space of nothingness, a cosmic womb. Quirky tidbit incoming. Some Kabbalists called this nothingness Ein Sof, or the endless. It wasn't just empty, it was infinite. Not void, but potential. A pregnant silence humming with all that could be but wasn't yet. You're wrapped in candlelight and vellum, and you notice something strange. Nothing is starting to feel holy. It's not absence anymore. It's the stage on which miracles perform. That strange theological alchemy turns nothing into a kind of divine resource. And depending on your denomination, it's either terrifying or deeply comforting. But not everyone agrees. Some thinkers argue that if God is eternal, then he always existed alongside something, or at least alongside the potential for something. Otherwise, how does creation even make sense? Did God just decide one day to invent time so he could finally get around to building a universe? Or was that all part of the eternal plan? Historians still argue whether medieval theologians actually believed in a true nothing, or if they were using it as a symbolic placeholder for divine mystery. The ambiguity makes you feel a little better about your own confusion. No one was sleeping well during this time, not even the monks. Then there's the curious matter of hell. Is hell something, or is it nothing, the absence of God, of grace, of being? Dante envisioned icy pits and screaming souls, but some philosophers argued that hell is more like a void, a spiritual zeroing out. The worst fate isn't torment, it's erasure. A chilling idea if you're trying to sleep. Sorry. As you tiptoe through monasteries and debate halls, you begin to notice how language itself gets twisty when dealing with nothing. Words like nihil, vacuum, non-esse, they point toward absence, but only by creating presence in your mind. Saying nothing creates a mental space. That's the ultimate paradox. To speak of nothing, you must make it something. You stop in front of a chalkboard covered in Latin and squint at a sentence that reads, Privatio est principium non es. Privation is the beginning of non-being. It sounds profound. It also sounds like it might be your cue to go find a cup of warm milk and lie down. Still, the debate rolls on. Can God create a rock so heavy he can't lift it? Is nothing really a state, or just a flaw in human vocabulary? Does the void have moral weight? Theologians scribble and pray and argue until the candles sputter out. And amid all the incense and whispered litanies, you notice that nothing has changed. It's no longer just a physical absence. It's become a philosophical tool, a theological battleground, a way of measuring divine power. That simple little word, nothing, is now pulling double, triple, even eternal duty. You step outside into the cold medieval night, the stars sharp and silent overhead. Maybe you're standing in a field. Maybe you're floating in conceptual space again. Either way, you feel the tug of all those arguments still hanging in the air. They're old, yes, but not gone. And you realize, the void may be empty, but the ideas we pour into it never are. You drift forward now through a swirling fog of symbols, looping curls of ink suspended in air like alphabet soup dreaming in Latin and Sanskrit. The mist clears, and there it is, a perfect circle. Not a sun, not a moon, just a quiet, dangerous zero. Welcome to the scandalous history of nothing's most controversial cameo, the number 0. It's small, it's round, and for a while it was considered too strange, too empty, and frankly too Eastern to be trusted. You pause midair above a crumbling scroll and look down at what might be the most suspicious digit of all time. In ancient times, numbers were serious business. They built pyramids, tracked harvests, and calculated taxes, but none of them for a long time could describe the absence of a quantity. You had 1 sheep or 2 sheep or, no sheep. But that no wasn't a number, it was a problem. Here's your mainstream historical fact. 0 as a mathematical concept originated in ancient India around the 5th century CE, where thinkers like Brahmagupta began to treat it not just as a placeholder in a number system, but as a number in its own right. A bold move, basically saying, yes, we'd like to quantify nothing, thank you very much. Imagine the courage it takes to say, let's do math with the void. That's like baking a cake with air and being proud of it. And yet, they did. Brahmagupta even wrote rules for adding and subtracting 0, and cautiously flirted with the possibility of dividing by it, though that part got messy fast. Try it on your calculator if you're feeling reckless. As this new way of thinking spread from India through Islamic mathematics and eventually into Europe, it brought with it an entirely new approach to counting, commerce, and geometry. Suddenly, place value made sense. Large numbers could be notated with ease. Equations could equal nothing, and that was allowed. But oh, how Europe resisted. When 0 arrived via Arabic numerals, it got the side-eye from monks and merchants alike. It felt foreign, dangerous, even demonic. After all, if zero could stand for nothing, did that mean it could undo something? Could it erase debt? Reverse divine order? Scary stuff for a society where hierarchies were literally ordained by heaven. Quirky tidbit for you. In 1299, Florence banned the use of Arabic numerals, including zero, because they were too easy to falsify. People thought merchants could sneak in or remove zeros to cheat buyers, and honestly, they weren't wrong. A single zero can turn a 1 into a 10 or a 100, magical inflation at your fingertips. But zero wasn't just controversial, it was revolutionary. It cracked the code for algebra. It made negative numbers possible. It gave mathematicians a way to express balance, not just presence. A universe of equations suddenly opened up, all because someone decided to give nothing a seat at the table. Still, zero always retained an aura of strangeness. Even now, when you multiply it with anything, no matter how grand, no matter how real, everything vanishes. You could be working with the mass of the sun and zero still calmly shrugs, "Nope, gone." It's like the grim reaper of arithmetic. Historians still argue whether zero truly represents nothing, or whether it's simply a symbol for the absence of something expected. Is it a value, a position, a placeholder, a concept, or all of the above wearing a tiny disguise? You glide through a medieval math lecture, one where no one's quite sure if zero is sorcery or science. They try to explain it using metaphors: the empty bowl, the blank slate, the silent note in a melody. But the metaphors all stumble because zero isn't just nothing, it's functional nothing. It's nothing that does stuff, a paradox in numeric form. And then something wild happens. As zero becomes more accepted in the Renaissance, it starts showing up in increasingly dramatic roles. Negative numbers emerge, solving equations that once seemed impossible. The Cartesian coordinate plane springs into being, with zero at its center, marking the intersection of all possible positions. Suddenly, nothing is the middle of everything. In fact, modern physics couldn't function without zero. It's baked into Newton's laws, Einstein's tensors, and quantum field equations. Absolute zero, zero temperature, isn't just a chilly concept. It's the point at which molecular motion completely stops. The lowest possible energy state, a kind of material stillness that borders on philosophical. But even here at this frigid frontier, nothing proves deceptive. At absolute zero, certain quantum systems still jitter. Thanks to the Heisenberg uncertainty principle, particles can't fully sit still, which means, even when physics gives us a zero, it can't stop it from doing something weird. It's like trying to calm a hyperactive cat by turning off the lights. You pause mid-narration, floating above a chalkboard scrawled with equations. Zero is everywhere now: your bank account, your odometer, your internet speed during outages. But it's still unsettling if you stare at it too long, because deep down it's not just a number, it's a door, a strange circular keyhole into everything that is. And here's something to tuck under your pillow: zero didn't just quantify nothing, it made it useful. Before zero, absence was just an empty spot on the table. After zero, absence became part of the menu. You can't help but smile. Somewhere, Brahmagupta is sipping celestial chai, watching a modern physicist type a zero into a quantum simulator, and thinking, "Told you so." You step softly into a new kind of silence. It hums somehow, not with voices or particles, but with mathematical certainty. The floor beneath you is smooth, flat, and infinite. It has no edge, no up, no down. You're standing inside Sir Isaac Newton's idea of space, and in his vision, nothing finally gets a backdrop. To Newton, space is real. Not an illusion, not a relational trick, but a genuine, three-dimensional stage upon which the universe performs its celestial ballet. You glance around and realize this stage doesn't wobble, doesn't curve, doesn't flinch. It just is. Welcome to absolute space, an empty container where objects move, forces act, and time ticks on like a divine grandfather clock. Here's your mainstream historical fact. Newton's Philosophiae Naturalis Principia Mathematica published in 1687, laid out a vision of motion that assumed the existence of absolute space and time. In this framework, space wasn't made of anything, but it existed independently of the objects inside it, like an invisible aquarium housing cosmic fish. You float through this space now, passing orbiting planets that move not because they're told to, but because they obey a deeper set of rules. Newton's laws of motion and universal gravitation work flawlessly here. No void panic, no metaphysical gymnastics, just elegant cause and effect. But as always, there's tension. Newton believed God had created this infinite space, and while it appeared empty, it wasn't really nothing. It had properties. It had structure. He described it as the sensorium of God, a divine interface through which the Creator observed the universe, which, let's be honest, is a poetic way of saying even nothing wasn't safe from surveillance. Still, compared to earlier ideas, Newton's space was remarkably hands-off. It didn't push or pull. It didn't guide or resist. It was just there, patiently waiting to be filled with apples, moons, and cannonballs. You picture it like a cosmic spreadsheet, rows and columns stretching endlessly in every direction, empty cells waiting for values to arrive. But not everyone was buying it. Leibniz, Newton's philosophical rival, argued fiercely against absolute space. To him, space was not a thing but a relationship between things. There's no such thing as empty space, because space only exists between objects. If you removed all matter from the universe, there'd be no points of reference, and therefore no space at all. Imagine a chessboard with no pieces and no players. Does the game still exist? For Leibniz, the answer was no. Without relationships, space is meaningless. Newton naturally thought this was nonsense. Historians still argue whether Newton's absolute space was a clever simplification or a necessary assumption. Some see it as a brilliant model that made physics work. Others view it as a metaphysical leftover disguised as scientific insight. Either way, it shaped the next 200 years of science. Here's your quirky tidbit. Newton tried to prove the existence of absolute space using a thought experiment known as the rotating bucket. Fill a bucket with water, spin it, and watch the water's surface rise along the edges. Even if everything else in the universe was still, the water knows it's rotating, evidence, Newton claimed, of space itself providing an invisible frame of reference. You squint at the bucket, not quite convinced, but it's hard to argue with spinning physics. As you drift through this Newtonian cosmos, everything feels stable, predictable. You could take a nap here and wake up with your velocity exactly unchanged. Forces act where they should. Masses attract each other as they're told. Even the moon keeps excellent time. But of course, that eerie stillness has its price. Newton's space may be passive, but it's also eternal, unchanging, indifferent. You start to feel the chill of it. Not cold exactly, but aloof. There's no wiggle room in this model, no surprises, just math humming in the background like a divine spreadsheet, infinitely large and infinitely blank where you're not standing. And yet that blankness made science possible. Before Newton, space had been messy, filled with invisible substances like ether, or shaped by mysterious forces. After Newton, we had coordinates. Motion could be described with precision. Astronomers could predict eclipses centuries in advance. Nothing became a grid, tidy, reliable, and blessedly unromantic. And that's the shift, really. Under Newton, nothing isn't dangerous anymore. It's not divine or chaotic or unknowable. It's just background. You can work with it, write formulas across it, even ignore it when it's not useful. It's the kind of nothing you can build rockets from. But something nags at you. If space is absolute and infinite, why does it feel so staged, so prefabricated? Like a blank canvas waiting for a painter that never arrives. It's too clean, too perfect. You start to suspect that nothing has been given a bit too much structure. You reach out and touch the space around you, only to realize that you can't. Because in Newton's view, space isn't in anything. It's not made of anything. It simply is. The backdrop to all being, a zero with grid lines. As you float back into your sleepy spiral, you carry this image with you. The universe as a massive stage, its floor made of invisible coordinates, its walls lined with infinite potential. Newton didn't kill the void. He domesticated it, gave it a job, taught it to sit still and mind its manners. And for a while, that was enough. You're still hovering in that neat, infinite Newtonian grid, everything tidy, labeled, and politely Euclidean, when something strange begins to happen. The air, if you can call it that, thickens. The grid starts to warp. The perfect right angles sag. Time ticks and then ticks slower. You've just stepped into the mind of René Descartes, and in here, the void doesn't stand a chance. Descartes is the kind of guy who stares into space and suspects it's lying. To him, true emptiness is not just suspicious, it's impossible. After all, if God is perfect and God created the universe, why would he leave gaps in his creation? That would be like building a house and deliberately leaving holes in the walls just for fun. God, in Descartes' view, doesn't do drafts. He's more of a fill in every last corner type. So Descartes declares, no voids, none, nada. He proposes that the universe is completely full of something. Even in places where there seems to be nothing, there must be something, because a true vacuum would be an imperfection. You raise your eyebrow, but he's already packing back and forth through his geometric diagrams, murmuring cogito ergo sum like a philosophical mantra. Here's your mainstream historical fact. Descartes' 17th century physics heavily relied on what he called a plenum, a completely full universe. Every bit of space was filled with subtle matter, swirling in vortices that carried light, motion, and even planetary orbits. To him, the idea of action at a distance was absurd. Things had to touch to move each other. That meant no empty space, no lonely atoms, no isolated fields, just an ocean of somethingness everywhere. You glance down and notice you're knee-deep in invisible whirlpools, Descartes' vortices, gently tugging on your ankles. It's weirdly calming, like standing in slow-motion surf made of physics and Catholic guilt. But his logic isn't just about metaphysics, it's theological. Descartes believed that God's perfection required the universe to be complete in every sense. So a void, a vacuum, a missing piece, unacceptable. That would be like accusing God of sloppy work. And in 17th century Europe, accusing God of anything was not a wise career move. And here's your quirky tidbit. Descartes believed that the laws of nature were enforced moment by divine will. That's right. He didn't think gravity or inertia operated on their own. He thought God was actively reapplying the laws of physics every instant, like someone furiously hitting refresh on a very divine webpage. Historians still argue whether Descartes' rejection of the vacuum was more philosophical than empirical. After all, he didn't have access to the tools that would later prove the existence of near vacuums. He was working with ideas, logic, and a strong sense of religious propriety. But the result was clear. For Descartes, space without substance was an impossibility. So what fills the space if not atoms or fields? Descartes proposed a kind of subtle matter, an invisible, imponderable stuff that flows around and between objects, transmitting motion like gears in a clock. It's like someone took the idea of molasses, removed all the sugar, all the color, all the taste, and said, now this is the stuff of stars. As you drift through his model, you start to feel crowded. Everything's touching everything else. There's no wiggle room, no breathing space. It's a universe of perfect connectivity. Beautiful, maybe, but also a little suffocating, like sleeping under 1,000 weighted blankets made of philosophy. You pause by a floating diagram, a planet wrapped in nested whirlpools of subtle matter, each ring pushing the next like a conveyor belt. This is how Descartes explained gravity. No mysterious attraction, just a giant cosmic eddy. The Earth doesn't pull the moon, it nudges it along with gentle whirlpool hugs. Of course, not everyone bought this. Newton himself would later demolish the vortex model with his equations of gravitation. But for a while, Descartes' vision ruled the French-speaking scientific world. And honestly, you kind of get it. It's elegant in its way, dense, deterministic, and unapologetically full. You reach out and try to touch the space around you, but like in Newton's model, you can't quite grasp it. Only now, it's not because space is nothing. It's because it's everything. Descartes has filled the cracks with logic and divine intent until the entire cosmos feels like a single solid object. And yet there's a comfort here. A world with no emptiness means no isolation, no randomness, no lurking voids to swallow you whole. Everything is connected, pressed gently into everything else. You're never not touching something. You're never truly alone. But it's also a little claustrophobic, isn't it? No room for surprise, no room for emergence, no space for silence. And just as you think that, just as you start to yearn for a tiny scrap of breathing room, Descartes vanishes into a swirl of his own logic, and the plenum starts to fade. The space around you lightens, loosens, opens. It turns out, humans weren't quite ready to give up on the void, and soon enough someone else will crack the vacuum open like a philosophical piñata. For now, you float in the afterimage of fullness, with a whisper of doubt brushing your ear like a breeze sneaking in through a church window. Maybe the universe doesn't have to be completely filled to be complete. Maybe nothing has a place after all. You feel it before you see it, the stillness shifting. The quiet isn't quite so quiet anymore. It hums with a promise, as if the emptiness you floated through is waking up, not bursting, not crackling, just trembling gently like a breeze against silk. You open your eyes and you're not in Descartes' divine whirlpool anymore. That stuffy universe of subtle matter is gone, replaced by something eerily calm, something invisible but full of secrets. You're floating now in the late 19th century, suspended in the one thing Victorian physicists really couldn't let go of, the ether. Not to be confused with the anesthetic that knocks people out, though honestly, the comparison isn't that far off. The ether was the ultimate invisible crutch of classical physics. It was supposed to be the thing that filled the void, not because people were afraid of nothing, but because they needed something to carry light. After all, if sound needs air and water waves need water, surely light must need something too, right? Here's your mainstream historical fact. By the mid-1800s, most physicists believed that light waves traveled through a mysterious substance called the luminiferous ether. This invisible, massless medium supposedly stretched through all of space, perfectly still, totally undetectable, except that you needed it for the math to work. It was like saying, hey, I know this thing isn't visible or touchable or measurable, but trust me, it's everywhere. Which, as you might guess, is the scientific equivalent of a toddler explaining how a ghost moved their juice cup. But it wasn't just fringe. This was mainstream physics. The ether was a serious candidate, a key part of electromagnetic theory, especially after James Clerk Maxwell's equations predicted that light was an electromagnetic wave. Waves need a medium, ergo, ether. It was so widely accepted that maps of the cosmos casually included it. Space wasn't empty, it was filled with this invisible jelly. You float now in this theoretical jelly. It doesn't feel thick or heavy. It's the kind of presence that's almost a non-presence, an elegant patch for a deeper hole in understanding. It behaves how scientists need it to behave, stiff enough to carry light but soft enough not to resist planets moving through it. Basically, the Goldilocks of undetectable goo. And here's your quirky tidbit. Scientists got so committed to the ether that they even imagined it could be dragged by planets like atmosphere clinging to the surface. Others argued it stayed perfectly still while Earth moved through it, like a boat cutting through glassy water. A lot of effort for something nobody could ever actually see. But belief in the ether wasn't blind. Physicists were trying to test it, most famously with the Michelson-Morley experiment in 1887. They expected to detect differences in the speed of light depending on Earth's movement through the ether. Instead, they got nothing. Light moved the same speed no matter what. no drag, no ripple, just stillness. That result, it was the beginning of the end for ether, but people didn't drop it immediately. Some doubled down. They tweaked models, invented ether drift, and added complexity to salvage the idea. Because letting go of the ether meant accepting something terrifying, that space might really be empty. Historians still argue whether the ether was ever anything more than a placeholder. Some say it was a perfectly rational step based on what science knew at the time. Others see it as a cautionary tale of how easily we invent invisible things just to keep the equations comfortable. And yet, there's something oddly charming about the ether. It represents a moment in science when people were trying to fill a gap, not with myths or gods, but with something testable, something you could poke at, even if it poked back with silence. As you drift through this old idea, you start to see its beauty, not because it was right, but because it was honestly wrong. The ether was a human attempt to understand the unseeable, an elegant fiction holding the place of a deeper truth yet to be revealed. And that deeper truth, it's already starting to whisper at the edges, because while the ether fades, a new idea is being born, one that doesn't fill space with jelly but bends space itself. One that doesn't need a medium for light, because light doesn't ride anything. It's the fabric of reality vibrating at full speed. You're on the cusp of a revolution, and it's coming with clocks, elevators, and one very famous head of uncombed hair. But for now, you float just a little longer in the ghost of the ether. It's quiet here, with only the faintest shimmer of Victorian optimism. The idea that we had to fill space with something, because nothing was just too hard to accept. And maybe, just maybe, that impulse to patch the unknown with something soft and scientific isn't weakness. Maybe it's what keeps the questions coming, even when the answers collapse. You feel the ether thinning now, its silky fabric unraveling like a dream at dawn. The invisible jelly dissolves, leaving behind only motion, light, and the faint electric tingle of something big approaching. You blink and suddenly the grid, gone. The smooth floor you've been floating on. It curves, folds, warps like paper soaked in time. You've just slipped into the most elegant demolition of nothing yet, Einstein's universe. There's no fanfare, no explosions, just a quiet mathematical coup in 1905, when a young patent clerk with wild hair and a polite disregard for Newtonian authority decides to rethink how space and time behave. His name is Albert Einstein, and he's about to rip the floor out from under classical physics. Here's your mainstream historical fact. Einstein's theory of special relativity replaced the idea of a fixed space and time with a single, dynamic fabric, spacetime. And just like that, the comfortable notion of an absolute backdrop was gone. No more invisible grid, no more cosmic spreadsheet. In this new model, space isn't passive. It stretches, it contracts, and most importantly, it reacts. What used to be nothing is now capable of being curved by mass and energy, which means that space itself has properties. It's not just where things happen, it is something. And that's only the beginning. In 1915, Einstein upgrades the chaos with his general theory of relativity. Now gravity isn't a force pulling across empty space. It's the shape of spacetime itself, warping around anything with mass. You float now through this curved geometry, watching planets orbit like marbles rolling along a bent trampoline. The void. It's not a void anymore. It's an active participant. Einstein's equations are mercilessly beautiful. They describe how the presence of matter tells spacetime how to curve, and how the curvature of spacetime tells matter how to move. There's no need for ether, no cosmic jelly, no Newtonian cage. Nothing has been absorbed, transformed, rebranded. Here's your quirky tidbit. Einstein initially resisted the idea that the universe could be expanding. His equations wanted it to, but he didn't believe it, so he added a fudge factor called the cosmological constant to hold it still. Later, when astronomers found the universe really was expanding, he reportedly called the constant his greatest blunder. Of course, Modern physics brought it back, because the universe just loves a good plot twist. Historians still argue whether Einstein's spacetime really counts as a something or a nothing. After all, it can be curved, shaped, and even contain energy, qualities we don't usually give to empty things. But it also isn't made of matter or particles. It's more like a medium that breaks all the rules of media. You float deeper into curved space now, and the disorientation begins. Distances shrink near gravity wells, time slows, light bends. Even the idea of straight lines becomes slippery. You reach out for some kind of frame of reference, but the only one left is yourself. And then you hit the speed limit. Because in Einstein's universe, nothing can go faster than light. Not sound, not rockets, not regret. This isn't just a practical rule. It's a fundamental boundary baked into the nature of spacetime. That means nothingness can't be crossed instantly. Signals take time. Even in the emptiest void, light has to do its patient, universal crawl at 299,792 kilometers per second. You think back to Newton's absolute space, rigid, eternal, unchanging, and realize how far we've come. Space isn't empty anymore. It's alive with tension and topology. Even a vacuum, in Einstein's terms, has structure. Coordinates don't mean anything without reference points. Time doesn't tick the same way for everyone. Nothing isn't nothing. It's relational. And the implications just keep piling up. Black holes. They're not just collapsed stars. They're places where spacetime itself caves in, creating a boundary, an event horizon, beyond which even light can't escape. It's not that there's nothing inside. It's that we literally can't know. It's a kind of forbidden silence. You drift toward one now, skimming the outer rim. You feel time stretch and slow. From your point of view, the fall into the black hole takes forever. From someone else's, you're gone in seconds. This isn't just physics, it's poetic disintegration. Even nothing takes different forms depending on who's asking. And just when you think Einstein has emptied every corner of classical physics, he leaves you with one last surprise: the possibility that space could exist without matter. That is, a vacuum solution to his equations. Pure geometry, unspoiled by stuff. A nothing that isn't really nothing, because the field equations themselves are still there, etched invisibly into the curves of spacetime. You float there a moment longer, between the echoes of collapsed stars and the stretched skin of gravitational wells, and you feel it. The eerie, majestic quiet of a universe where the background is the star of the show. No longer just where things happen, but how they happen. Nothing in Einstein's universe is never really empty. It's pregnant with geometry, pregnant with potential. A field of possibility waiting to be curved into motion. And as the warping fades and your perception returns to its sleepy blur, you realize the void never really existed the way we once thought. Space was never a blank slate, it was a living script. And the pen, just mass, light, and time. The curved geometry around you begins to smooth out. The gravitational grip of massive stars relaxes. The spacetime trenches fade like sleep lines on a pillow. But just when you think you're returning to a peaceful, well-behaved void, a strange twitch ripples through the dark. You're not alone here. The vacuum is restless. You've entered the quantum world now, and the rules. They're upside down, inside out, and written in glitter ink by a universe that finds your expectations adorable. You're drifting in what seems like emptiness, but this is Einstein's dignified spacetime. No, this is a frothing, jittering, impossible to sit still quantum field, and it absolutely refuses to shut up. Here's your mainstream historical fact. In the 20th century, physicists realized that even empty space isn't really empty. Quantum field theory tells us that fields, like the electromagnetic field, the Higgs field, and others, pervade all of space. These fields can fluctuate even when there are no particles present. So what we once called nothing is actually a sea of activity, a quantum vacuum. Imagine you're trying to take a nap on a trampoline while someone flicks it very gently from underneath forever. That's quantum vacuum energy, and you can't turn it off. It's the lowest possible energy state of a field, but it's not zero. It's not peaceful. It's twitchy, buzzy, and always up to something. You look around, and if you could see this level of reality, you'd spot virtual particles popping in and out of existence like shy fireflies. They're not quite real, not quite fake. They appear, exist for a fraction of a second, then vanish again. You can't catch them. You can barely prove they were there, but they leave traces. And here's your quirky tidbit. These virtual particles aren't just a metaphor. They're part of real, measurable effects. One famous example, the Casimir effect. If you place two metal plates extremely close together in a vacuum, they actually attract each other. Why? Because the space between them suppresses certain vacuum fluctuations, and the imbalance causes a tiny but very real force. That's right, two objects in empty space are pushed together by nothing. This kind of vacuum isn't passive. It has properties, it has pressure, it contributes energy to the cosmos. It's as if the universe is whispering, "You thought I was quiet, think again." And at this scale, the difference between something and nothing becomes a blur. Historians still argue whether the quantum vacuum counts as a form of existence or just a mathematical abstraction. Some say it's the true ground state of reality. Others insist that even calling it empty is misleading. After all, it's not just a backdrop, it's a participant. It births particles, affects motion, and this part's wild, may have helped shape the entire universe. Because guess what? This restless vacuum isn't just a scientific curiosity, it might be the mother of everything. In many models of cosmology, the early universe arose from quantum fluctuations in an unstable vacuum. A little wiggle here, a little blip there, and boom, inflation, particles, stars, cats. And remember Einstein's so-called greatest blunder, the cosmological constant. It turns out that the vacuum has energy, a lot of it, enough to explain why the universe is still expanding, accelerating in fact, which means nothing isn't just active, it's pushing galaxies apart. You try to wrap your head around this. The vacuum isn't just not empty, it's possibly the most powerful thing in existence. The force that sculpts spacetime, spawns particles, and drives the expansion of the universe is what we used to call nothing. It's a bit like finding out that the floor you sleep on at night secretly controls global politics. You trusted it to be passive. Turns out it's got opinions. And yet, for all this energy, for all this motion, the quantum vacuum is still subtle. It doesn't shout. It hums. The fluctuations happen too fast, too small for you to feel. It's like living on a trampoline made of dragonfly wings. You drift deeper, watching the fabric of space flutter and fizz. Virtual particles appear and vanish. Electrons and positrons, gluons and ghosts. They aren't stable, but their effects are. You can't photograph the vacuum's flickers, but they shift the energy levels of atoms. They bend light near black holes. They even change how clocks tick. Which brings you to an unsettling realization. The deeper you go into nothing, the more something you find. Emptiness is like peeling an onion. Each layer reveals more complexity, more rules, more behavior. The void is no longer absence. It's a medium, a matrix, a dance floor. And yet it's still called vacuum, still labeled as 0 point, still sold as the ultimate absence. Why? Maybe because we haven't found the bottom yet. Maybe because the human brain insists on using the word nothing, even when faced with a buzzing, particle-birthing, universe-expanding field of wild quantum nonsense. Or maybe it's just tradition. Either way, you float now in a place where the boundaries between being and not being are paper-thin and constantly shifting, where the fabric of existence is never at rest, even in its quietest moments. It's not a void. It's a heartbeat you can't hear. And you know what? You kind of love it here. This version of nothing is weird, yes, but it's alive. It hums with curiosity. It makes room for magic and math. So go ahead, close your eyes. Let the virtual particles dance behind your lids. Let the vacuum buzz beneath your thoughts. Because in the quantum field, even nothing refuses to sit still. The vacuum pulses around you now, not like a heartbeat but like a whisper trying to decide whether it should become a scream. You're still weightless, still afloat in the quantum hush, but something's changed. The fluctuations feel sharper, briefer, hungrier. And then without warning you see it. A flicker, a blip, a pair of particles popping into existence before your very eyes, only to vanish again before your mind finishes blinking. Congratulations, you've just seen virtual particles in action. The jittering, ephemeral ghosts of the quantum vacuum. They appear uninvited, steal a bit of energy from existence, and disappear just as quickly, like thieves who return the wallet before anyone notices it's gone. The vacuum, it turns out, is a playground for these ghostly intruders, and their behavior may hold the secret to why anything exists at all. Here's your mainstream historical fact. Virtual particles are a key part of quantum field theory. They're not real in the classical sense. You can't detect them directly, but their effects are measurable. They mediate forces, tweak atomic energy levels, and explain phenomena like Hawking radiation and the Lamb shift. And they only get away with this trickery because of one of the most unsettling principles in physics, the Heisenberg uncertainty principle. You probably remember the greatest hits, like how you can't precisely know both the position and momentum of a particle at the same time. But there's another version of the rule that applies here, the uncertainty between energy and time. What it means basically is that if you're dealing with a very short amount of time, you're allowed to borrow a little energy from the universe. Just a little, and only briefly. But if you're fast enough, so fast that the universe doesn't notice, you can buy a particle-antiparticle pair, let them exist for a whisper of a moment, and then pay it back before the quantum cops show up. Quirky tidbit time. The idea of virtual particles is so baked into modern physics that we now use them to explain why atoms don't fall apart. That's right. Without the jittering effects of these not-quite-real particles, even the stability of matter would be suspect. Your couch, your coffee, your cat, they all exist in part because of particles that technically don't. But let's not get too comfy, because these virtual particles might also play a starring role in something a little more apocalyptic. Let's talk about Hawking radiation. Stephen Hawking, that smirking genius with the robot voice and the universe-sized mind, realized something extraordinary in 1974. If you apply quantum mechanics to the edges of a black hole, specifically the event horizon, weird things happen. Imagine one of those virtual particle pairs forms right at the edge. One falls in, the other escapes. From far away, it looks like the black hole has emitted a particle. And over time, as more of these pairs form, the black hole loses mass, slowly, in tiny sips. Eventually, if you wait long enough, it might evaporate completely. A paradox of cosmic scale, the most unstoppable force in nature slowly leaking away into nothingness. Historians still argue whether this process actually destroys information, which would break some of the deepest laws of quantum theory. This is known as the black hole information paradox, and it keeps very smart people awake at night, while the rest of us fall asleep peacefully on our quantum field-supported mattresses. You float now near the edge of a theoretical black hole, watching virtual particles flicker in and out of being. It's not violent, it's not loud, it's more like a slow hiss, like a kettle boiling in dimensions you can't see. This isn't radiation in the traditional sense. It's math humming at the event horizon, slowly unraveling the cosmos. And here, where it gets truly weird, some physicists believe that this vacuum-based behavior, this twitchy background activity, isn't random. It might contain subtle patterns, hints, messages even. There are theories very fringe, very whispered, that virtual particles might be influenced by past or future states of the universe, that the vacuum could be a kind of quantum record keeper, or worse, an editor. In other words, the vacuum is no longer just reacting to physics, it might be enforcing it. Which leads us to a question that feels simple, but is anything but. If virtual particles can emerge from the vacuum, what's stopping them from becoming permanent? The answer, not much. Just a bit of borrowed energy paid back with interest. But what if they don't vanish? What if the universe blinks and forgets to collect the debt? You're thinking of cosmic inflation now, that rapid expansion of the universe right after the Big Bang. Many cosmologists believe it may have been triggered by a fluctuation in the vacuum, a virtual something that refused to go quietly. It didn't fizzle, it exploded. And suddenly, space itself expanded faster than the speed of light, dragging baby galaxies along for the ride. And all of that might have started with a single hiccup in nothing. You shiver, even though there's no temperature here. You're floating in a space that shouldn't be empty but also shouldn't be full. A place where nothing is busy birthing some things. A place where the laws of cause and effect are suspended, or at least blurred beyond recognition. And now brace yourself. The vacuum isn't just active, it's unstable. Yes, we're going to get to vacuum decay in the next section. But for now, hold this in your sleepy mind. The vacuum you rest in, the ground state of the universe, might not be the true ground. There could be a lower state, a deeper nothing. And if we ever tunnel into it, even by accident, the entire universe would instantaneously, painlessly, and completely disappear. Not with a bang, not with a scream. Just gone. But don't worry, that probably won't happen for another trillion years or so, probably. Now roll over, let those virtual particles buzz gently beneath your dreams, and let nothing keep whispering its nothings into your ears. You drift now through a space that hums with possibility, but under that hum there's a tension, a pressure you can't quite name, something like the creaking of floorboards in a room you thought was empty. It's not loud, it's not even clear, but it's there. This is no longer the gentle restlessness of the quantum vacuum. You've crossed into a more volatile realm, a place where nothing is not just twitchy, but temporary, where what we call the vacuum may not be the final word. Welcome to vacuum decay, the existential nightmare hidden in physics textbooks, disguised behind polite equations and awkward terminology. Don't let the sleepy phrase fool you. This is about the end of everything. Let's start gently. In quantum field theory, the vacuum isn't just empty space, it's a field configuration. Think of it like a ball resting in a valley. If the valley is deep and stable, that's the true vacuum. But what if the ball is resting in a shallower dip, a false vacuum? It feels stable, but only until something nudges the ball over the edge into the deeper valley. Then the whole field configuration changes, instantly, irreversibly. Here's your mainstream historical fact. In 1980, physicist Sidney Coleman and collaborators explored the idea of vacuum metastability, the possibility that our universe exists in a false vacuum and could, one day, tunnel into a true vacuum state. If that happens, a bubble of the new vacuum would form and expand at the speed of light, rewriting the laws of physics as it passes. Imagine waking up to find that your bed, your atoms, and the concept of bed itself no longer exist, not because you exploded, but because being is no longer an allowed state. The tricky part, you wouldn't even see it coming. The bubble would travel faster than light. One moment you're you, the next you're unhappened. Here's your quirky tidbit. This possibility isn't just theoretical. The math checks out. And when scientists measured the mass of the Higgs boson back in 2012, it landed in a range that suggests our universe might be just slightly unstable. Not guaranteed to decay, but not guaranteed not to either. Historians still argue whether this counts as science fiction or hard physics. Some say the odds of vacuum decay are infinitesimally low, like worrying about a cosmic anvil hanging above your head. Others warn that under the right energy conditions, like in high-energy particle collisions, we could accidentally trigger it ourselves. Good news, our current technology is nowhere near that powerful, so go ahead, finish your snack. You float now in a half-dream, picturing a pinprick of new vacuum forming in the void. A new set of physical laws, maybe different masses, maybe no atoms, no chemistry, no stars, just a new universe, infinitely different, erasing the one before it. And you begin to feel the most unsettling truth of all. This would be completely natural. The universe wouldn't flinch. It wouldn't care. It wouldn't even blink, because blinking requires eyes and time and beings who measure both. But here, where it gets beautiful, stay with me. Even if vacuum decay is possible, even if nothing hides a deeper, more fundamental state beneath our own, you're still here, lying in bed, breathing, existing. The particles that make you up have obeyed the current vacuum's laws for 13.8 billion years. They've held their ground through expansion, heat-death flotations, and countless quantum coin flips. That stability might be temporary, yes, but it's also astonishing. So what do you do with this knowledge? You float with it. You don't panic, because if vacuum decay ever does happen, there's no warning, no suffering. It's the cleanest exit ever devised. The universe changing costume mid-act with no audience left to notice. You pause in that idea. Let it settle like soft dust. You are living in a cosmic maybe, a bubble of stability within a sea of unknowns. And isn't that always the case? Not just in physics, but in dreams, in love, in memory. We all float in a kind of probable space. Hopping the ground beneath us is the deepest valley and not a temporary shelf. And now, sleeper, you've reached the soft curve of the script, the turning point where even nothing begins to relax. The danger has been acknowledged, the questions asked, the stakes named. So now we slow. You drift not through vibrating fields or explosive decay, but through something softer, quieter, the spaces between ideas, the silence between virtual particles. Let your breath slow with it. Let your thoughts get heavy, not sharp, not panicked, just warm. The vacuum isn't coming for you tonight. The particles are quiet, the fields are at rest. In this moment, nothing isn't a threat or a paradox. It's a place to lie down. No motion, no urgency, just the cosmic hush that existed before questions were invented. The same hush that waited for the first star. And will still be here long after the last one fades. Now exhale, let your body melt into the mattress. Let the possibility of silence carry you. Let it become your pillow. There is nothing to fix, nothing to fear. Only nothing. And maybe that's enough. You stir gently, but the silence doesn't break. Not yet. You're suspended in it now, a delicate cradle of stillness woven from field lines, imaginary particles, and whispered potential. The vacuum hums, but softly, like a lullaby just out of reach. You survived vacuum decay, at least for now, and that's no small feat. But there's more waiting in the darkness. Because even after all the nothing we've explored, the void still has a surprise tucked under its silent sleeve. Something pushy, unrelenting, expansive. Tonight we meet dark energy, the most suspicious kind of nothing yet. It creeps in gently at first, a force not tied to particles or pressure, something embedded in the fabric of space itself. You notice it by watching galaxies. They're drifting apart, sure, but something's off. They're not just coasting, they're accelerating, as if some invisible hand is pushing them away from each other faster and faster. Here's your mainstream historical fact. In 1998, two independent teams of astrophysicists discovered that the expansion of the universe isn't slowing down, it's speeding up. This shocking realization led to the revival of Einstein's abandoned cosmological constant, now reinterpreted as dark energy, a mysterious force accounting for about 68% of the total energy in the universe. That's right. Most of what exists, more than stars, gas, dark matter, dust, and bad decisions, is nothing. Or to be more accurate, it's something we call nothing because we don't know what else to call it. It's not made of particles. It's not energy in the usual sense. It doesn't clump or shine. It doesn't care. You float now in a vast, quiet galaxy cluster. The space between the galaxies stretches, slowly at first, then faster and faster and faster. There's no wind, no force you can touch, but the distance grows all the same. It's not the galaxies that are moving through space, It's space itself that's stretching. And that stretching is powered by dark energy. You whisper, "What is it?" But space doesn't answer, because the truth is, we still don't know. Some theories propose it is the vacuum energy, the zero-point jittering you explored earlier, scaled up to cosmic levels. Others suggest it's a new field like the Higgs lurking beneath reality. A few brave souls think it might be evidence of a fifth force, or a wrinkle in gravity we've misunderstood for 100 years. Or worse, something our math can't capture. And here's your quirky tidbit. According to recent models, as the universe expands, the influence of dark energy increases. It's not like ordinary energy that thins out in a bigger space. No, dark energy seems to accumulate. The more space you have, the more dark energy you get. Like a cosmic frequent flyer program that keeps adding miles even when you're not flying. That's where things get eerie. If this acceleration continues unchecked, we could be heading toward a future event called the Big Rip. It's exactly as fun as it sounds. Over billions of years, dark energy could grow so dominant that it not only pushes galaxies apart, it begins pulling galaxies apart, then solar systems, then atoms. Eventually, in the final seconds, even the fabric of spacetime itself could tear. No explosion, no collapse, just a smooth, unstoppable stretch into utter separation until nothing remains connected to anything else, not even within itself. Historians still argue whether this outcome is supported by the data. It's only one of several endgame scenarios. Others include heat death, the slow drift into thermodynamic equilibrium, or a big freeze, where the expansion never stops, and stars burn out one by one into an infinite dark. But the common thread, dark energy doesn't go away. It keeps acting, keeps pushing, a nothing that insists on being more. You begin to realize something unsettling but beautiful. The emptier the universe gets, the faster it grows. The more lonely it becomes, the harder it pushes outward. It's like the cosmos is allergic to stillness, trying to outrun its own silence. You drift through this expansion now. Galaxies fade into pinpoints. The Milky Way becomes a whisper. Eventually, even the light between clusters grows faint. In a future ruled by dark energy, entire galaxies may become unreachable, moving away faster than the speed of light. Not because they're traveling through space, but because space itself is stretching beneath them like an escalator that never ends. There will come a time, billions of years from now, when civilizations might look into the sky and see nothing. No galaxies, no evidence of the Big Bang, no hints of the cosmos that came before, just darkness, just silence. And they might think their pocket of stars is all there ever was, that the universe is static and local and small. But you know better. You know that even the emptiest void hums with history, that even a vacuum has a memory. So what is dark energy really? Is it a leftover from the Big Bang, a flaw in spacetime, a hidden code, or just a name we give the part of the universe that's smarter than us? We don't know, but we do know it's there. So tonight, as you lie still and let your body fall towards sleep, remember, the nothing outside your window is alive. It moves the stars. It stretches the galaxies. It writes the future on a scroll of space that grows longer with every passing breath. It's not chaos, it's not malice, it's not even lonely. It's just dark energy. Still pushing, always pushing. You drift now through silence so wide, so deep, it barely feels like a place at all. Stars are far behind you. Galaxies are thin as whispers. The void stretches, not with loneliness but with mystery. But this isn't the cold stillness of a finished universe. No, this is the furious hum of a universe just beginning. You've arrived at the edge of time, a fraction of a second after the beginning, the place where nothing didn't just tremble, it exploded. Welcome to the era of cosmic inflation. Here's your mainstream historical fact. In the 1980s, physicist Alan Guth proposed the theory of cosmic inflation, suggesting that the universe underwent a period of exponential expansion in the first 10 seconds after the Big Bang. It didn't just grow, it ballooned. A region smaller than a proton suddenly expanded to the size of a grapefruit, or maybe even larger. You hover at that moment now, as if standing beside a firework mid-spark. But what's unsettling isn't the speed, it's what came before. Because inflation doesn't just describe an early growth spurt. It offers an idea so strange, so slippery, it might be the wildest twist in the history of nothing. Before everything, there may have been a quantum vacuum. And that vacuum, a flat, seething nothingness, might have been all there was. You remember that quantum jitter from earlier, the virtual particles, the buzzing vacuum. Turns out those weren't just noise, that instability might have sparked inflation. A single quantum fluctuation, just one, could have tipped the balance. The false vacuum, full of energy, tunneled into a true vacuum and boom, space expanded faster than the speed of light. Not into something, not within something, space itself expanded from itself into itself. And just like that, the universe was born. Here's your quirky tidbit. Some versions of inflation theory suggest this process didn't just happen once. It may still be happening. In distant, unreachable corners of the cosmos, pocket universes might be budding off like bubbles in boiling water, each with its own physics, its own constants, maybe even its own version of you wondering about nothing. It's called eternal inflation. And in this picture, our entire universe is just one room in an infinite, inflating mansion that never stops building new rooms. The vacuum is no longer a canvas, it's an architect. You pass through that foamy birth space now, feeling the warping and stretching around you. Space isn't smooth here, it's quantum foam, a frothy sea of Planck-scale fluctuations. At this scale, even spacetime isn't continuous. It's choppy, uncertain. You're watching geometry stutter, watching causality get wobbly, watching the most basic concepts, space, time, distance, start to vibrate. Physicists sometimes describe this as the quantum foam, a term coined by John Wheeler in the 1950s. At this tiny, primal level, the universe flickers between being and not being. Little wormholes may form and pop. Tiny baby universes might spark and vanish. It's all speculation, of course, but it's informed speculation. Historians still argue whether the quantum foam is a physical structure or a mathematical artifact, something our equations predict, but our instruments will never touch. Some believe it's the bridge between general relativity and quantum mechanics. Others think it's just noise. But if we ever hope to understand what nothing truly is, we have to wrestle with this fizzing chaos. And here's the kicker, that bubbly, frothy vacuum. It might be timeless. In some inflation models, there was no before inflation because time itself emerged with inflation. That means the vacuum didn't occur in time, it became time. Let that sink in. The thing we call nothing, this shapeless, foamy pre-spacetime stew, gave rise to the clock. It didn't just wait for the Big Bang, it enabled it. You exhale slowly, weightless now, as if you've been dropped inside a thought too large for language. There is no edge here, no reference point, just the soft roar of a vacuum inventing existence from itself. This is where the meaning of nothing becomes irretrievably weird. Because what do you call a void that can produce universes? That froths, inflates, and folds space like origami. That pulses with uncertainty but never stops ticking. You call it potential. Not absence, not silence, but the seedbed of everything. You realize now that the journey from nothing to something wasn't a line. It was a bounce, a twist, a billion tiny flukes lining up to spark the one moment where the laws of physics could unfold into music, molecules, and mildly disappointing traffic patterns. And if eternal inflation is true, it's still happening, right now. Countless other universes might be inflating beyond our cosmic horizon, each born from the same quantum foam, each whispering its own version of physics into the dark. And yet here you are, in this one. Not an accident, not a necessity, just this. You feel a stillness rise beneath all that noise, a soft gravity of calm even as the quantum foam buzzes at your feet. The vacuum might be unstable, it might be loud, but for this moment in this patch of existence, it's your cradle. You rest your head back on the edge of space-time, and maybe, just for tonight, that's enough. You're floating again, but this time it's not through anything foamy or expanding or explosively confusing. No ripples, no inflation, just stillness, deep, dark, and almost quiet. You're sinking now toward the question that may never be answered. Does a true vacuum exist? Not a quantum vacuum, not a field-filled spacetime, not a helpful placeholder or theoretical trick. You're hunting for the real nothing. The one with no particles, no energy, no fields, no jitter, no time. A silence so complete it forgets to echo. But does it exist? You drift through this question like smoke through a lock. It has no sharp edges, just a growing sense that we've never seen, touched, or measured true nothing. Every time we peel a layer back, something's still buzzing underneath. Here's your mainstream historical fact. Modern particle physics defines a vacuum not as the absence of everything, but as the lowest energy state of a quantum field. This vacuum isn't empty, it contains fields. It can fluctuate. It's shaped by boundary conditions, symmetry breakings, and the odd hiccup from a virtual particle. It's busy, it's loud, but it's the best we've got. And yet some theorists dream of a deeper level, a true vacuum, a state with no fields, no interactions, no information, something beyond even quantum uncertainty. Maybe it's unreachable, maybe it's forbidden, or maybe it's just not there. You pause in your drifting and try to imagine it. What does true nothing look like? And here's the trick, you can't. The moment you try, you fill it with darkness, with silence, with metaphor, but if it has a color, a temperature, a shape, it's already not nothing. Even calling it true vacuum gives it a name, a label, a conceptual handle, and that handle breaks the illusion. It's like describing a hole by talking about the dirt you removed. The moment you describe it, you've disturbed it. Here's your quirky tidbit. In 2013, a team at CERN created one of the highest vacuum environments ever achieved on Earth, just a few atoms per cubic centimeter. But even in this ultra-deep emptiness, quantum effects still danced. Photons still flitted in and out. The nothing was absolutely crowded. Historians still argue whether a true vacuum is even a scientific concept or just a philosophical placeholder. Physics deals with what can be observed, measured, or modeled. But what happens when you try to model the absence of everything? You can write equations, but you're writing them on something, inside something, relative to something. And relativity, by the way, has its own opinion. In general relativity, even empty space has curvature. That means a pure vacuum isn't just empty, it has geometry, which is a problem because geometry implies structure. And structure, that's not nothing. You're starting to see the trap now. At every level, cosmic, quantum, mathematical, we keep chasing nothing, only to find a new kind of something waiting at the bottom. It's like digging a hole and discovering the earth has no floor, just more layers of topsoil all the way down. Some physicists have turned to string theory for answers, but it's not exactly helping. In many string models, the vacuum is defined by the shape of extra dimensions curled up at every point in space. The vacuum isn't just empty, it's a product of how spacetime is folded, which again means it's not nothing. It's origami made of math. And here, where things get strange, there may be many vacua. In some theories, the landscape of possible vacuums is vast, maybe even infinite, each one with different physical laws, constants, and behaviors. You're not looking for the vacuum, you're browsing a menu of vacuums. And yet true vacuum, the one that strips away even potential, still missing. Maybe we've misunderstood the assignment. Maybe the universe was never supposed to include nothing. Maybe existence is the default, and non-existence isn't an option. like software that runs by default because there's no off button. Think of a computer running 0 programs. That's not nothing. That's a system idling. It still has a screen, power, a clock. Maybe true nothing is like asking for a state that can't be instantiated, even in principle. And maybe, somewhere beyond physics, there's a final silence, a true, absolute nothing. Or maybe not. You lie back against this question, letting it press against your spine like a soft, heavy thought. You don't need an answer tonight. You just need the hush, the possibility, the weight of something so empty it escapes imagination. Maybe we'll never measure a true vacuum. Maybe it doesn't exist. Or maybe it's what we came from and will never return to. You hover now in a strange hallway. The walls aren't walls. They're mathematical membranes, paper-thin and trembling, stacked in dimensions you can't see. You turn your head, but space turns with you. Time seems optional here. Everything feels adjacent. This isn't just the edge of your universe. It's the suggestion that there may be others, entirely different ones. And you're about to meet the idea that makes nothing even more complicated than it already was. Welcome to the multiverse. Not one universe, not one vacuum, but a cosmos of cosmoses. Let's start slow. Here's your mainstream historical fact. Modern cosmology, especially in the context of eternal inflation and string theory, suggests that our universe might be just one of many, a pocket of stability in a much larger, inflating multiverse. Each universe might have different physical constants, different particles, even different dimensions. And in that sprawling theoretical landscape, nothing becomes relative. You drift between bubbles now, each one sealed in its own space-time. Some are tiny and burn out immediately. Others inflate into galaxies and stars. But all of them start the same way, as quantum fluctuations in a foamy vacuum. The same nothing that gave birth to you may have birthed everything. Some physicists call this the string theory landscape. In this model, the number of possible vacua, possible configurations of the vacuum state, is not 1 or a dozen or even a million. It's estimated at 10^500. That's a 1 followed by 500 zeros. So many options that you begin to wonder, maybe nothing isn't the absence of something, it's the set of all possible somethings. Here's your quirky tidbit. Some versions of string theory allow for compactified dimensions, extra spatial directions that are curled up too small to detect. And the way these dimensions are folded helps determine the properties of each universe. Which means the vacuum isn't empty, it's folded, like a napkin with 11 dimensions and attitude. And in these theories, the vacuum isn't just a passive setting, it's a selection mechanism. The kind of vacuum you get determines the kind of universe you get. In one, gravity might be stronger. In another, atoms might not exist. In another, the laws of physics could prevent matter entirely, or thought, or cheeseburgers. Truly nightmarish. Historians still argue whether the multiverse is science or philosophy, because here's the catch: we may never be able to test it. These alternate universes could be completely sealed off from ours, causally disconnected. There's no way to visit, measure, or poke them with a telescope. And yet the math works. The ideas persist, not because they're comforting, most aren't, but because they solve problems. They make the equations balance, and they let us imagine a new role for nothing, not as an absence but as a choice, a variable, a fork in a trillion-dimensional road. You drift now through one hypothetical membrane, a vacuum bubble like yours but older. It feels thinner, cooler. Maybe its constants were slightly different. Maybe it inflated longer. Maybe life arose and collapsed eons ago. Or maybe it never started, just sterile atoms and unobserved time. And what about before the bubble formed? What did the vacuum look like then? In eternal inflation models, that pre-bubble state is a high-energy vacuum. A false vacuum, just like the one you met in section 13. But here's the twist. This false vacuum never settles. It keeps inflating, rapidly, randomly, endlessly. Every bubble that forms is a universe, but the space between them still inflating. Which means there's no central origin, no beginning, no final end, just a never-ending birth of everything from a vacuum that never goes quiet. You feel dizzy. You reach out, try to touch something real, but everything's slippery. Here, the void is not stillness. It's possibility turned aggressive. A vacuum not as a resting state, but as a machine for making everything that can be made. Some theorists even argue this solves the fine-tuning problem. Why does our universe have exactly the right constants for life? Because if you have 500 universes, at least one of them has to get lucky. And we're in it. It's not design. It's statistics. And then there's the existential angle. If every possibility exists somewhere, what does that mean for you? Is there another you in another bubble who turned left instead of right, who never asked about nothing, who became a dolphin trainer, who never existed at all? In multiverse theory, nothing is almost impossible to define, because somewhere something always exists. Even the void is busy. Even the in-between spaces may be something else to someone else. And here's the deeper ache. If everything exists somewhere, does that make anything meaningful? It's a heavy question, too heavy for bedtime, so let's set it down gently. You curl up now in one of these bubble universes, your universe, the only one you'll ever truly know. The laws feel familiar, the physics cozy, the constants just right for carbon, breath, sleep. And maybe that's enough. The multiverse may be real, it may not, but this patch of nothing, this singular, vibrating void you call home, is yours. And as you drift off, membranes fluttering in dimensions you'll never see, you hold onto one last thought. Maybe you don't need to know what's outside your bubble. Maybe you just need to breathe and let it be. You drift now in the soft hush of a dying star's echo. It fades into blackness, not with a bang, but with a long, drawn-out sigh. Time feels thick here, stretched thin like taffy, warped by gravity and regret. You're nearing one of the strangest, stickiest paradoxes in the cosmos, the one that suggests that nothing might be keeping secrets. Tonight, you're falling gently into the gravitational grip of a black hole, not physically, not dangerously, but intellectually. Because nestled inside these cosmic sinkholes is a question so sharp, so weird, it slices open the very meaning of absence. Can information ever truly disappear? Let's start at the edge. You float near the event horizon, the boundary beyond which nothing, not even light, can return. Cross it and you're gone. Not just physically gone, but causally disconnected from the rest of the universe. But here's the wrinkle. In physics, information is sacred. It's not supposed to vanish. Even if you burn something, melt it, crush it, the information about its original state is still, in theory, preserved. Rearranged, sure, but not deleted. So what happens to the information that falls into a black hole? That's the heart of the black hole information paradox. Here's your mainstream historical fact. In the 1970s, Stephen Hawking showed that black holes aren't entirely black. Thanks to quantum effects near the event horizon, they slowly emit radiation, now called Hawking radiation, and over time they evaporate. This was groundbreaking, but also horrifying, because if black holes evaporate, what happens to all the stuff that fell in? Hawking's original answer: the information is lost forever. Cue physicists collectively losing their minds. That answer breaks the most fundamental law of quantum mechanics, unitarity. The idea that quantum processes are reversible and no information is ever truly erased. If Hawking was right, the black hole wasn't just a cosmic garbage disposal, it was a data shredder, a place where existence becomes untraceable. But physics hates that. You float closer now, watching imaginary objects fall in books, planets, politicians. And then slowly, over trillions of years, the black hole shrinks, emitting soft radiation. Eventually, it vanishes. The stuff is gone. The question remains, did the universe just lose track of what happened? Quirky tidbit time. In the 1990s, physicist Leonard Susskind challenged Hawking's view, proposing that information isn't lost, it's encoded on the surface of the black hole. This gave birth to the idea of the holographic principle, where the information content of a volume of space can be fully described by data encoded on its boundary. In other words, reality might be a hologram. Yeah, you're in that part of physics now. Historians still argue about the full resolution of the paradox. Most physicists today believe that information is preserved, possibly scrambled in Hawking radiation, or encoded in correlations we don't yet understand. But no one agrees on the exact mechanism. Some think black holes never fully evaporate. Others think they leave behind stable remnants. And a few suspect we're missing something profound, something that may rewrite how we understand time, entropy, or even causality. So what does all this have to do with nothing? Everything. Because the black hole should be the ultimate nothing, a place from which no information escapes, where entropy reaches its max, and where spacetime folds in on itself like a cosmic cul-de-sac. But if information is preserved, then even this nothing is actually something. Not a loss, but a lockbox. A perfectly secure, if annoyingly inaccessible, archive. And here, where it gets beautifully absurd, the more we study black holes, the ultimate voids, the more we find structure, patterns, even rules. A black hole has a surface area, a temperature, a thermodynamic profile. You can't see what's inside, but you can calculate it. Its entropy is proportional to the area of its event horizon, not its volume, which suggests that what you call nothing is again just misunderstood. You drift now at the edge of one such hole, watching its event horizon shimmer. Is it storing the past? Is it projecting the future? Maybe it's both. Maybe, as the holographic principle suggests, the three-dimensional world is an illusion emerging from a two-dimensional edge, like a movie projected from film. And if that's true, then maybe the entire universe is like a black hole, a bound system, a finite space with an informational boundary. Maybe even the deepest vacuum, the most quiet corner of space, is not a blank page but a palimpsest, overwritten with hidden text we haven't learned to read. You feel something turn in your mind quietly, as if nothing isn't lack but hidden structure, a cosmic save file compressed beyond comprehension. You can't feel it, you can't parse it, but it's there. The vacuum doesn't forget. Even black holes don't forget. Which means maybe the universe doesn't either. So the next time you feel like you've left no trace, remember this: even your molecules, even your thoughts leave imprints. The physics of it says so. The universe, it turns out, is a hoarder. And nothing, it might be the biggest archive of all. You wake slowly this time, not because something jolts you, but because the quiet is thinking. Not vibrating, not rippling, not expanding or collapsing, but considering. You're not in the domain of physics anymore. The math is still here, faintly, like chalk dust in the air, but the questions are shifting. Less about what space does and more about what it means. You've floated all the way back to the surface, into philosophy, where nothing is older than galaxies and harder to define than quantum foam. This is where language loops back on itself, where metaphors outnumber measurements, and where even your confusion has a 1,000-year pedigree. Tonight, you drift through the modern metaphysical rebound, the grand return to the question that began all others. What is nothing, really? You're not alone in asking. From Heidegger to Sartre, from Wittgenstein to modern analytic philosophers, the 20th and 21st centuries have taken a second look at the void, not just as a physical vacuum, but as a conceptual abyss, a space where meaning, being, and identity become optional. Here's your mainstream historical fact. In 1929, German philosopher Martin Heidegger gave a now infamous lecture titled, "What is Metaphysics?" in which he asked one of the simplest, strangest questions in the history of thought. Why is there something rather than nothing? A sentence so casual it could fit in a fortune cookie, and so heavy it could flatten your dreams. Heidegger wasn't asking for a scientific answer. He wanted you to feel the unease. The dread, yes, capital D, that rises when you confront the idea that maybe everything could have not been. That there might have been no stars, no thoughts, no definitions. That existence itself is, somehow, extra. Philosophy doesn't try to solve nothing. It tries to sit with it. But other thinkers took different approaches. Jean-Paul Sartre, for example, flipped the script. In Being and Nothingness, 1943, he argued that nothingness isn't a void, it's a function of consciousness. You can't even conceive of nothing unless you're something. Your very awareness of absence creates absence. If you walk into a room expecting to find someone and they aren't there, the negation of their presence is something you invented. The room hasn't changed. You have. Quirky tidbit time. Sartre also believed that freedom, the terrifying, overwhelming humankind, was rooted in this nothingness. That who you are isn't a stable self, but a constant act of not being something else. In other words, your identity is shaped by the things you are not and the choices you haven't yet made. That's existentialism for you. Sleep tight. Historians still argue whether philosophy has anything left to say about nothing, now that physics has gotten so good at turning it into equations. But don't be fooled. Physics still depends on language, and language still wrestles with limits. Even in science, nothing is a placeholder, an approximation, a word that gets redefined at every scale, and philosophy's job is to point that out. To remind you that words aren't transparent windows, they're stained glass, bending meaning as light passes through. You float now in a sea of questions, not equations but paradoxes. Can you name nothing without making it something? Can you think about nothing without dragging thought into it? Is nothing the absence of being or a kind of being in itself? Maybe the idea of nothing only makes sense because of how humans are built, how our minds are obsessed with contrast, with duality. Black needs white, up needs down, something needs nothing. Or maybe nothing is our attempt to escape the weight of everything, a spiritual exhale, a way to imagine peace when the universe won't stop shouting. You turn slowly toward Ludwig Wittgenstein, the philosopher who famously ended his Tractatus Logico-Philosophicus with this line: "Whereof one cannot speak, thereof one must be silent." You linger there in that line. It feels like a doorway, or maybe a closed door. Because perhaps that's the final form of nothing, silence. Not an absence of matter, not a vacuum or a collapsed probability wave. Just the end of saying. A point at which the question loses its shape. You breathe in, and for once the air doesn't buzz with particles. It doesn't shimmer with vacuum energy or ripple with space-time curvature. It just isn't. And that non-presence feels oddly whole, oddly restful. You're not lost, you're not falling, you're just here, at the softest edge of understanding. Because maybe nothing is less a concept and more a mirror, one that shows you what you bring into the room, what you expect, what you fear, what you're trying to escape. And that's where philosophy leaves you, not with answers but with echoes. Echoes of the thought you almost had, the silence you almost understood, the words you almost found but didn't. So let them echo. Let the unanswered questions curl around your dreams like fog wrapping a distant hill. You don't need to solve the mystery. You only need to hear it. Because tonight, nothing isn't an object or a place or a vacuum. It's the hum between your thoughts. It's the shadow behind every definition. And it's been with you the whole time. The darkness deepens, but not with fear, with finality. The kind that doesn't close doors but leaves them gently ajar. You're lying still now, wrapped in all the questions, all the bubbles, all the jittering quantum maybes. And as the last pieces settle, one final idea begins to surface. Not a theory, not a proof. Just a possibility. Maybe nothing never was. Not in the ancient sense. Not as the blank canvas that came before the brush. Not as the cosmic prequel to being. Maybe we invented it, a linguistic ghost conjured from opposites, from logic, from dreams of erasure. You lie still and trace the idea backward. You've seen so many kinds of nothing. Aristotle's forbidden vacuum, the atomist's enabling void, the theological silence of creation, Zero's rebellious neutrality, Newton's static backdrop, Einstein's curved spacetime, the quantum field's jittery hush, the froth of eternal inflation, the pushy nothingness of dark energy, the information-storing paradox of black holes, the reflective silence of metaphysics. Every time we've thought we reached nothing, we found something else hiding there. Energy, fields, fluctuations, meaning, memory, motion, time. Even the concept of a true vacuum, empty of fields, particles, and potential, crumbles under scrutiny. Because to know it, to name it, is already to make it something, a variable in your thoughts, a ripple in your awareness. Here's your mainstream historical fact. In the modern physics community, the term nothing has largely been replaced with specific descriptors: quantum vacuum, false vacuum, zero-point field. Because the word nothing is too slippery, too human, too haunted by history to be scientifically useful. And here's your quirky tidbit. In a 2012 debate between physicist Lawrence Krauss and philosopher David Albert, the two clashed over the very title of Krauss's book, A Universe from Nothing. Krauss argued that quantum laws allow the universe to arise from the vacuum. Albert retorted, but that's not nothing, because the laws were already there. The fields, the framework, something. Which leaves us here. Maybe nothing isn't the opposite of being. Maybe it's the artifact of language trying to describe absence. A placeholder for what we can't imagine. An echo of a question that never needed asking. Because the more we look, the more we see that the universe doesn't sit on top of nothing. It emerges from something strange and irreducible. A jittering sea of laws and fields and potentials that we call nothing, only because we're out of better words. Historians still argue whether early humans ever truly grasped non-being, or whether we simply used the word nothing to mean not here, not yet, or not what I expected. And that's the trick. Nothing is always defined by what isn't there, but that definition requires something else to contrast it with. Try to think of pure, total, metaphysical nothing. No space, no time, no laws, no concepts, not even awareness. You can't, because the thought itself breaks the rules. So maybe nothing is just a mental canvas, a place we paint fears, theories, and bedtime paradoxes, a tool, a metaphor, not a place the universe came from, but a shape we made when we looked into the dark and needed it to mean something. You feel yourself falling now, not in space, not in time, but into stillness. You don't need to answer the question. You just need to hold it gently. Let it rest beside you like an unopened book. Because in the end, the question did give you something. It gave you 20 sections of wonder. It gave you galaxies of thought. It gave you an excuse to lie down and breathe and imagine. And that's not nothing. That's everything. So now just breathe. Let the noise fade. Let the question dim. Did nothing ever exist? Maybe not. But the asking, that was beautiful.